Welcome. In this video, we will learn about how to design a learning system. First, we have to choose a better training experience. The type of training experience available can have a significant impact on success or failure of the learning system. Choosing of training experience mainly depends on three attributes. First attribute is whether the training experience provides direct or indirect feedback regarding the choices made by the performance system. In direct feedback, for every position, there is a fixed feedback that is to be followed. In indirect feedback, from the available feedbacks, user has to select correct one. That selection leads to successful or unsuccessful. Even though current one is good selection, depending on next selection, result changes. Direct feedback is easier than indirect feedback. Second attribute is the degree to which the learner controls the sequence of training examples. If the user selects correct one by taking teacher's advice or user selects some moves, ask teachers help for correct one, or user improves his performance by playing with himself without taking teacher help. In the latter stage, user has more control on sequence of training example. Third attribute is how well it represents the distribution of examples over which the final system performance P must be measured. The final system performance is judged by considering all possible ways. For example, in a chess playing system, its performance is to be measured by considering how it plays with ordinary players, grandmasters, and itself. The next design choice is to determine exactly what type of knowledge will be learned and how this will be used by the performance program. This leads to choosing of correct target function. For example, in the board game, target function is selecting best move from all existing moves. Choose move is B implies M, where B is set of legal board moves, M is best move. Alternate target function we can take as V is B implies R, where R is real value which is mapped to different board moves. How to take real values to the different board states? Here is the example. If B is arbitrary board state, then V of B depends on B. If B is a final board state, that is 1, then V of B equal to 100. If B is final board state, that is last, then V of B equal to minus 100. If B is a final board state, that is drawn, then V of B equal to 0. If B is not a final state in the game, then V of B equal to V of B complement, where B complement is the best final board state that is to be achieved. Learning algorithms to acquire only some approximation to the target function. So, target function is often called function approximation V cap. Previously, we have specified the ideal target function V, but learning program function is to be represented by function approximation V cap. To take this, first we need to identify different board features and for each feature assign different numerical coefficients. In this example, function approximation V cap is represented as W0 plus W1 x1 plus W2 x2 and so on, where W0, W1, W2 are numerical coefficients, and x1, x2, x3 are different board features. In the previous video, we have taken initial design for checkers game by using task, performance measure, and training experience. Here, that design is extended by adding target function and its representation. This is considered as a partial design for checkers learning program. To choose function approximation algorithm, we have to consider estimating training values and adjusting of weights. V train of B is used to represent estimating training values. Each training example is represented in an ordered pair B, V train of B. V train of B is derived from V cap of successor of B, where V cap is function approximation and successor of B is next move to be played by the system. It comes after current move of the system and opponent's move. Adjusting of weights depends on least mean square weight update rule. This is to be carried out when the resultant function value is not best fit in the model. To make it as best fit in the model, we have to adjust numerical coefficients in the function approximation. To perform adjusting of weights, we have to take difference value of V train of B and V cap of B. If the difference value is 0, then there is no need to change weight values. If difference value is a positive value, then we have to increase weight values. If the difference value is a negative value, we have to decrease weight values. Here is the final design for the learning system. It is described by four distinct program modules. First one is performance system module. It must solve the given performance task. In each iteration, it takes an instance of new problem state as input and produces a trace of its solution as output. For example, in the board game, it gives V cap as output for each given state as input. Second module is critic module. It takes a solution trace as input from performance system module and gives training examples as output. Third module is generalizer. It takes training examples as input and produces hypothesis as output. Last module is experiment generator. It takes current hypothesis as input and gives a new problem, a new board state as output, which is to be again input to the performance system module. The role of experiment generator is to pick new practice problems that will maximize the learning rate of the overall system. Here is the summary of choices in designing the checkers learning program. First, we have to determine type of training experience by considering all three attributes. Next, we have to determine the target function by considering real values of board states. Next, we have to identify representation of learned function by using function approximation. Finally, we have to design learning algorithm. Thank you.